So we see an equal sign, so we're solving this equation, and I want one of these sides to be 0 first. So even though it looks like they were trying to do some good here by having this already factored, we have to undo it. So what I'm going to do, I'll just go by the steps I said before. I'm going to subtract the 40 over to make this right side be 0. So I'll have x times x minus 6 minus 40 equals 0. So one side's equals 0, but I can't start to factor this until I distribute this out. So this is x squared minus 6x minus 40 equals 0. And you're good with factoring these. This is a trinomial, so when you do this, you're going to get x, what was that, minus 10, x plus 4 equals 0. And now you're going to set each one of these factors equal to 0, because you know that if this times this equals 0, then one of these factors has to be 0. And that's why it's so important to have a 0 on this side, because there's no way to multiply to get 0 without one of these being 0. Like 5 times 0 is 0, or I don't know what I'm trying to say, but I'm trying to say that up here when it equaled 40, there's lots of factors that made 40. Maybe this was 4 and that was 10, or maybe this was 8 and that was 5. So neither one of those factors has to be 40 or anything in particular. We don't know. But when it's 0, the only way to multiply to make 0 is to have one of those factors be 0. So let's let each one of these guys be 0. So let the x minus 10 be 0, and let the x plus 4 equal 0, and then solve each one of these new equations that show up just like you have in the past. I'm just going to add 10 to both sides to get the x alone. So x is 10, that's one possibility, and subtract 4 there, so x is negative 4, that's another. So you have two answers, either x is 10 or x is negative 4. And those are your two answers. You could plug them back into the original, they'll work. 10 times 4 would be 40, and if you plug in the negative 4 times negative 10 would be 40. So, yay.